Oh, there's no clicking. It's all keyboard. It's all keyboard, and it's really powerful. And I would say for us, though we're a little gray right here, run it with a larger data set up on the cluster. We're going to give you, if you want to, grab about 100 cores, a couple of terabytes of memory, keep the time below 60 minutes.
Welcome back, fellow travelers, to another exciting episode of Tech Travels. In today's episode, we're going to dive into the topic around high performance computing, also known as HPC, and understand a little bit why this is a very critically important element around building artificial intelligence and machine learning models. Now, this is a very super complex topic, even for the most experienced technologist. So I thought, to help us understand this topic better, who better than to help us break this down into more digestible and funny and witty pieces of humor? None other than Brooks Seahorn, a
Hello,
true
everyone.
pioneer in the tech landscape. And Brooks, it's great to have you back on. Welcome back to the Tech Travels podcast.
Thanks, man. I'm glad to be back on. The first one was a hoot. I got a bunch of pushback on some things I said, so I'm excited to find out what happens with this one. Literally, the collective hold my beer after that episode. So let's see what happens with this one.
So I want to dive into this topic around high performance computing, but I also want to just kind of help set the stage for some of our listeners here. If I was a third grader, how would you explain high performance computing to me in a way that I can easily understand it?
It's interesting when you talk about it in those terms because, trying to really break it down like that, I kind of get to this point where I say this. Imagine if you could just snap your fingers, get a really big computer and get just the right features you need with just the right amount of memory, with just the right amount of CPUs and everything, do a job on it, like figure something out like your math homework, and then get the answer back, and then you release it. It's what we've talked about so long in the cloud. Cloud was always like, you only pay for what you consume. So you can build the biggest thing you want that you can immediately get rid of it. HPC is that way as well. Us as, wanting to build machine learning models, wanting to build artificial intelligence, things like that. Those are huge jobs that require huge computers. So HPC gives us a path into being able to say, give me that huge computer, literally thousands of CPUs, terabytes upon terabytes of memory, run the job, give me back the answer.
Mm-hmm. So this is just simply a way to us aggregate computing power that delivers more of a throughput for an outcome, right?
Exactly. That's exactly the idea. You've got some like gigantic ETL, extract, transform, load that you need to do. That's a great example of where you could do massive ETL jobs relatively quickly. Whereas normally, if you're just on your computer, on like maybe a really good desktop computer, it could take days, maybe weeks to complete the operation. With HPC, with that spread out of your resources, being able to get huge resources, that's where that come in. And let me put it in context for everybody what I'm talking about. Think of computers like Frontier at Oak Ridge Mountain up in Tennessee. This thing has like 9,400 CPUs inside of it. This thing is huge. And so that would give us the opportunity within the HPC space. If you were doing like an extract, transform, load to say, look, I need a couple of hundred CPUs because the transform is going to be massive and it's going to be a ton of work. But the thing is that I just only need it for this job. And once the job is done, I want to release those resources to other users. That's the basic concept of HPC, and that's why it's important to understand it.
And the interesting thing is this is not new, right? This has been something that's been out there since the 1950s and 1960s. I think I remember back, even people talking about the IBM Stretch supercomputer that was back in the 1960s.
Exactly.
So it seems like I think it used to use transistors. I think I studied in college around vacuum tubes, and really just thinking around how supercomputers at that time were really defined. So this is kind of almost, I would say, like, with artificial intelligence, with everything that's been happening in the AI space, there seems to be more of a renaissance to get back to the hardware, right? You remember a couple of years ago, it was, we moved off hardware and we moved to the cloud.
Right.
Now everything now is moving back to getting back to the actual kind of hardware, the CPU, the GPU, and then programming it at that layer. And I want to kind of understand a little bit more about this kind of this resurgence. What's caused this resurgence? I guess is maybe just the chat GPT, it's AI, it's the evolution, it's the revolution we're starting to see.
It is. And the thing is that I like the way you said that because it is almost like a revolution. It's like we're going back to, okay, I'm not going to use a GUI. I'm at the console. Oh, I need to think about how much memory I'm actually using. Oh, I need to think about releasing resources, consuming resources, things like that. Whereas, so often when we talk about technology, we're on our phone, some gee whiz interface, being able to talk to chat GPT, stuff like that. This is very basic stuff. This is command line, what kind of CPU you've got, having the hardware there may be usually the case. And this is what we're seeing with a lot of really large companies. They've got these giant clusters sitting there that they're taking advantage of. And it's getting back to the core of it. This is why so often people are surprised moving into AI and ML that there's these folks running these things. They're using these low down Linux systems and these low down Linux tools and all these really low, like, where do I click? Oh, there's no clicking. It's all keyboard. It's all keyboard, and it's really powerful. And I would say for us, though, we're a little gray right here, it's cool because it's like, yeah, that's the way we used to do it. And it's just to see the power of it come back to where we've got the power back is just so exciting.
It's incredible because even though the technology has been around for some period of time, roughly
Mm-hmm.
probably about 50, 60 years, we're
Mm-hmm.
seeing this resurgence back into it again. There seems to be a real kind of skills gap with people who've just never seen hardware like this before,
Right.
who are just coming into this. And I feel like there definitely needs to be a way for us to upskill. Talk a little bit about kind of what you're seeing in terms of kind of the evolution of the learner,
Right.
the advocacy around AI development and learning not just the language model, but getting
Mm-hmm.
down to the actual hardware elements itself. Kind of talk me through some of that.
When you start talking about AI and ML, a lot of us, and you and I were both the same way. We started learning about ML, we started playing with it, we started doing things with it, and it was great. But it was always within this context of, hey, isn't that fun? And we were doing it right here on our laptop. Maybe we had like a Jupyter notebook or something like that, or we ran something in the background, and it wasn't too heavy. It wasn't too intensive, and it allowed us to kind of play with some of the tricks of it. For those of you who are out there who currently have a tear rolling down your face, that deep lens, the Amazon or AWS deep lens has gone away. I still have mine. I wish
Yeah.
it worked. Mine is a complete brick. But this is when did we go to that, Steve? The event that we had and it was in Florida. Do you remember that one? You remember
Yeah,
that one?
it was it Tech Kickoff 2017, 2018, I think it
I think
was.
it was 2018. Yeah, we were getting you could go to that one class and walk away with a deep lens camera, so everybody was trying to get into it. But the thing was is that model was so simple. You could crush it right there on your machine. You could push it onto that device, have the model up in the cloud. That's fantastic. Here's the problem. If you've learned that way, and let's say you get hired by, and I don't want to name any companies, just think big company that may be using AI, ML in some way. When you get there, what you're liable to hear is something along the lines of, hey, that's a great model. Here's what we want you to do. Run it with a larger data set up on the cluster. We're going to give you, if you want to, grab about 100 cores, a couple of terabytes of memory, keep the time below 60 minutes. We do have H100s out there, so be sure to bring those in as resources that you can use. And your head's just starting to come off your head. You're like, off your neck, because you're like, what are they talking about? That's the skill gap, understanding what HPC is and how you can put your job up there. You don't have to necessarily know all the architecture and how things are actually working, but knowing it's there and knowing you can use it or should be using it for really big jobs. Steve, there are ML jobs that I know of out there that have run times of months
Wow.
in order for it to complete. And this thing is consuming, 1,000 CPUs, several hundred terabytes of memory, some of the biggest GPUs that you can think of to run over a couple of months on a machine like, like a Mac here or a Wintel box. Impossible. Can never be done. And so you've got to make that jump. How do I do that? And as far as the advocacy goes, I will say this to just about anyone. Start looking into the user tools of HPC environments. Now, I don't want to do any salesmanship here. I
Mhm.
do work for a company that supports one of the biggest open source HPC software out there. It's called Slurm. You can go check it out. It's completely open source, which to me is pretty amazing that it is in that state and you can just go grab it, run it, local and do stuff. Well, you'd have to do some work to get it to run. But the idea is that with that, you would start to understand, how do I actually put a job on a cluster? How do I actually do these things? And to be absolutely honest with you, without even doing that, there's a lot of documentation out there that could get you going in the right direction. So if you're really serious about AI and ML and you don't have that set of skills that can answer the question, how do I put this on a cluster? Start looking into it. Get yourself educated on it. It's open source, open documentation. You can find these things. And I highly encourage anyone, go out there and check it out, because it is going to be a big stumbling block for you, a big one, when you suddenly get that one day, when they show you the giant cluster. Like, I've seen these clusters before, Steve. There was one I was at a couple of weeks ago. They were showing it off to us, and I was like, wow, look at all the stuff. I mean, like, in cages I've never seen before. Like, one of their cage doors, several of the cage doors, they have water flowing through the door. Like, normally it's like oh no, it's in the door. There was an H100, for anybody out there who doesn't know what the H100. How much would that cost us, Steve, to pick up an H100?
I think they're right around $500,000 now, aren't they? $250,000.
The one that I saw was $500,000 configured. I was just like, oh my. When I saw it, knowing how to put a job onto that thing and use it is critical. And so that's where that stuff comes in, and that skill gap that can bite you shows up. It's, you know what it is? It's tantamount to this, Steve. Remember, we would talk to people about cloud, and we would get to networking, and we would say, okay, 192.168.00/24. Who doesn't know what this means? And the room was just crickets, because nobody knew IP addressing. They knew cloud, but not IP addressing. If you're in AI and ML and you don't know how to use HPC, you need to get educated on it. But that's just the first part of it. I'll come to the second part later.
Mm-hmm. I remember that I remember that we would do that exercise for students and learners, right? And you think about the explosion at which we're hitting artificial intelligence with large language model. Now, even with now with Microsoft's Phi 3, Phi 2, Phi 3, you're getting into smaller language models. Now you're looking at what Apple's doing with the ELMs, right? There's just a rapid pace of innovation. And I think back to when we would talk a lot about Moore's Law. And I love this concept, right, around Moore's Law. And it was basically 10x every 5 years, 100 times every 10 years. But it seems like, and I'm just going to throw it out there, is that seems like Nvidia, they've gone 1,000x over the last 8 years, and there's 2 more years to go. But with that being said, how do you, the pace at which innovation is happening is just so fast speed. I feel like the moment watching Spaceballs again, when we go a ludicrous speed, go.
Exactly. And the thing about it is, it is kind of ludicrous. What flips me out about the thing, though, is that, there's still so many people out there saying, okay, you don't have a great business case yet. I don't know. I've seen some real good business cases where I've used tools like that to get jobs done really, really fast. Now, was it correct? No, it wasn't 100%. But I'm telling you what, it sure cut down the work time on it. So yeah, it's out there, and it starts making you wonder, moving at the speed that Nvidia is innovating. Keep in mind, they put the Grace Hopper chips out there. Is it the Blackwell that are coming out next in the fall? Oh my goodness. And these things are even faster than that. Once you start getting into those speeds, and everybody, this is the point Steve and I are making here. Once you get into that kind of performance, those big LLMs, you can run them a lot faster. You can make them a lot smaller. Suddenly they're sitting on your watch trying to help you out in just the journal. So my thing has always been kind of like, I don't expect it to be some big business driver. I really don't. I'm almost seeing it as like this incredible assistant that's going to live in and around in our lives to really make things better. Now, of course, we do have the challenge of, I want AI to wash the dishes and fold the clothes. I don't want it the other way around. I don't want to be folding the clothes and doing the dishes. So yeah, AI is over there actually doing my job for me. But we're kind of seeing a little bit of that. So at that speed of innovation, and by the way, Intel's CEO came out this morning on that very point, talking about Moore's Law, talking about the speed of innovation, talking about Nvidia, because that's got them all spooked over at Intel, is because of what those GPUs are doing. Going back to HPC, knowing, for example, what a GPU is, how it works, how to take advantage, like if you're doing, the different types of mathematics that you can take advantage of on a GPU that runs much faster. Knowing how to call those out in a job and take advantage of them, you got to know how to do it, everyone. You've got to know how to do it, because once you get to that space, you can figure it out. Yeah, they may show up, know what you're doing. Just show up knowing what you can do. You'd be a lot better off. Good
So
gravy.
so fun anecdote, right? And this is from a great source at ChatGPT. It says, I ran this experiment through it, and I wanted to kind of give it. Remember, we were going back in our first podcast. We were talking about the lack of humor in artificial intelligence. I
Yeah.
think OpenAI was listening to our podcast. Because here we go. All right. So the fun anecdote is this: the comparison humor between kind of where NVIDIA is heading with the Blackwell architecture is using traditional computing for AI tasks is like trying to tow a jumbo jet with a bicycle. With high performance computing and Blackwell, it feels like you've swapped the bike for a rocket engine.
Mm-hmm. Mm-hmm. Exactly.
I mean,
Exactly.
not far from really true here.
Yeah, and the thing is, that talking about our last podcast, this is what came back to bite me. That whole hold my beer moment. Do you remember I popped off about how AI couldn't get the muddy sound in music that I can get when I pull down one of these guys back here and I can get that? I had somebody within a week, I didn't tell you about this, Steve, within a week, send me a muddy sounding bass line. And to make it muddy, he trained the model to take some of the strings, and what'll happen is when it vibrates too big, everyone, it'll hit the fret, the metal fret, and you'll get that ringing sound. He injected it into it. And then on top of that, it was almost like he figured out how do I get a grainy AM radio sound and put that on it. Put it into the model to the point of now you just put the note, you send the note, you got this muddy sounding bass guitar. And again, it's that speed of innovation. When you have chips like what we're talking about that can crunch down that data in a big hurry and get it out there, now you're at a situation, I think, Steve, where not only is it, oh, you've come up with a great idea, but how fast can you get that model created and pushed to the market? Remember that whole thing about how fast can you get your feature into production? How fast can you get that LLM squashed down and ready to roll on that device?
Yeah, it's a really good question. I think that's the biggest thing. I think IDC did a study where they said 55% of most organizations are still trying to figure out what
Um,
their position on AI is, right? What their
mm-hmm.
foundation is, and trying to understand what it is that they're trying to solve for.
Right.
Almost every single day, I kind of hear a lot of requests for, hey, talk about AI, talk about some prototyping, some sort of MVP. And the
Mm-hmm.
question always goes back to what exactly is the problem? What exactly the problem is that you're trying to solve for? What is the desired business outcome? And a
Mm-hmm.
lot of it is vague. It's very ambiguous. And I don't think that they are really truly able to define exactly what it is that they're trying to do with it. I feel like we're kind of we're still at very early stages, the early adopters.
Mm-hmm.
And you're right. Those who are going to figure out how to rapidly prototype something to get it into kind of into either customer facing or as much into their environment as possible, that's going to have the best total cost of ownership, the most return on investment. I think that's going to be kind of a winner. And I think most are probably still kind of maybe still scratching your head on it, right? Trying,
Yeah.
what is this widget?
Yeah, what is this thing? What is this tool? I mean, it literally is like walking into like a mechanic shop, seeing a tool laying there. You go, wow, that's a powerful tool. I wonder what I could use it for. And like it's a couple places that are already is being used, but you get this idea that could be used in even a bigger space. And I think that's one of the things that gets me kind of like that when I think about people getting into AI and ML and not knowing HPC because of that thing right there. When you finally think of that, oh, wouldn't it be great too? Yeah, that would be great. Now, how are you going to get that model done as quickly as possible to get ahead of your competitor? Because I think, Steve, maybe you've seen this in your life. Have you ever done something where you've thought of this like great idea and then like 2 months later, somebody was doing it and you're like, hey, I thought of that first. That was my idea, like you didn't tell anybody. It's like there's this collective idea that descends on the planet and somebody does something with it. Understanding HPC, having access to HPC, and that's a little bit of that's going to be to me a little bit of a am I going to say the right word? De democ de, de
Democratization.
Yes, democratization. I don't know if that's the right word, but you remember we used to preach about that, like in the cloud, you can use anything if you can pay for it, and it's a lot cheaper. If you have access, if you're at an organization that has a giant HPC system, you're going to be able to feed it all that data to get that really good model that's going to become that incredible tool so that when you finally do think of, I know what I can do with this to actually be able to spit out that model and make it work.
You mentioned an interesting point. Working for an organization that has all the equipment, that has
Yeah.
the capital to be able to invest in the equipment, right? Um, do I need to be in an organization that has HPCs running in order for me to learn? Can I learn on my own? Is there a way for me to simulate running on an HPC or high performance computing cluster without actually having to pay for it? It seems like there might be a little bit of a a little bit of
Ooh. Yeah.
a little bit of a hook there.
Yeah, we said we've gone all the way back around to here again. We're all the way back to trying to get our CCNAs again back in the early 2000s, and nobody owns a router. So it's like, how are we going to learn how to do this to that thing when I can't afford one of those things? There are actually some simulators out there. There's actually one. We actually make one called DSO, Docker Scale Out. It'll allow you to basically um, simulate a 10 node environment with GPUs. It's very small. It runs inside a virtual machine. We have one. There's a few others out there that you can find that will allow you to do some simulation. If you're crafty, and I dare not show exactly how, I'm looking at it right there. You can actually install Slurm, the product that we kind of watch over, open source, remember, on Raspberry Pi 5s. You can do it. You can build a small cluster at home for a few $100 and actually do those sorts of things. So, is it absolutely free? No, it's not free. Our DSO is free. Running it inside a virtual machine, you have to do a little bit of work. You could do it on a Raspberry Pi 5 as well. And actually, the amazing thing about that, Steve, is if you do it that way, you would have to do it exactly the way it would be done with a giant cluster, because you're going to treat each one of those things like a node, put all the special, other machines in there that you want. So you can do it. It takes a little more work. Nobody has like a nice, go to this website and begin clicking. And if they do, I wouldn't trust it.
Just log in with your credit card. That's all we
Yeah,
need,
just
right?
log it. Yeah, and it's going to work just fine. No, it won't. No, it won't.
Okay. So there are simulators out there that can
Mhm.
give me the capability. I can build my own kind of quasi quantum computer with a
Well,
couple of
not
Raspberry
quantum,
Pis.
quantum, and HPC.
Well, HPCs. Well, it was going to kind of sorry, it was kind of moving into this direction here. Is quantum seems to be like kind of that potential future trend of
Yep.
HPC, right?
Yep.
Um, Kind of from your perspective, and it kind of help me understand a little bit of the context around separating exactly the difference between high performance computing and quantum, just broad spectrum.
Yeah, here's the thing about it, and this is what I've heard a lot from a lot of engineers in the space. Quantum to a lot of systems will simply become another resource in the HPC environment. It'll just become what we call a generic resource that you can reach out and use. And so at that point, and again, this is understanding how to use HPC. When you submit your job, you can make a request in that command line. Haha, command line. Yeah. You command line this thing and you make a request for it when it becomes available, like time on a quantum box. Now, there's a couple more things too that we have to talk about. For example, understanding application layout, understanding you're not going to do this in a language that's not supported in that environment. So we're back to things like C, C++, those types of language. Python does work well in HPC. I'm a big Rust. What do they call us? Rustaceans. Rust does have some support in HPC. So knowing how to write code in those particular languages obviously is going to be a big part of making sure it works. But that's really the end point of it, Steve, is like when a lot of these quantum machines become available, if you're in an organization that can afford one or can access one, it could become part of a cluster, and then it would become a resource that you could take advantage of when you actually push out there. So that's another big power of HPC. I would expect that once they become available, our fun friends at Name Your Favorite Cloud Provider will have them out there and you could spin up. And they have different HPC solutions as well. They're not going to be free. For example, a parallel cluster in AWS. You could spin up a cluster right there and experiment with it. Make sure you set your billing alarm, kids. And you could set it up. And then once they have quantum available, you could theoretically spin that up, add that to your cluster, and make that a consumable resource. So once quantum becomes available, I really see it as becoming, it's going to be a quick access for anybody who needs to be able to use it in an HPC environment.
Quantum's going to break AES 256, true or not? Debatable.
you hear the hesitation because I spoke to somebody not too long ago who I cannot name, who I absolutely trust, and he was like, "Yeah." I mean, that was his. It was like, "Yeah," and I was like, "Really, dude? You think so?" He's like, "Look, it's his point was well taken. Any key whatsoever that we use for cryptography is not for encryption; it's for time of encryption. How long do you need to protect that data set from being unencrypted?" Great story about this guy. He was going to a football game. I won't name it because I don't want to place him anywhere in the world.
Mhm.
It was American football, everybody. You know, the game where we only use our hands. Anyway, um, he was going in, and this was a long time ago. This is when he told the story, is about 10, 12 years ago. They were using these portable scanners to actually like credit card, print ticket, give it to people. Yeah, you can go in so you could buy it right there. Well, he was watching what they were doing. He was saying they were changing the batteries out pretty constantly. So what this guy did was is he literally went the next day because he used to be a member of, or he owned a consulting group before he became a C-level officer at a company. And he said, "I think you're over encrypting. I'm pretty sure you're over encrypting." They were using like a 256 encryption on these things. And he said to him, "You don't need to do that. You need to protect these tickets for about 10 hours. Once they have to let anybody hack it. Great, you printed a ticket for a game that's already happened. You're a knucklehead." So I think based on what he told me, yeah, he fully expects it. Now I kind of expect it. And it's just a matter of time because encryption, more than anything, is protecting data for a certain amount of time. And quantum can do it if the math all works out. Then yeah, it's going to crack it real fast. That's why you're seeing all these people coming forth and saying, "We've got a quantum proof encryption protocol." And I'm like, really? You don't even know what quantum is yet. And okay, great. Go ahead and do that. But at least it's a step in the right direction,
I,
potentially.
Uh, yeah, let's hope that it doesn't happen. A lot of my cryptographic keys are in AES 256.
Hmm.
Yeah, swerving back into HPC again. What I
Yeah.
find really interesting is when people talk about high performance computing, HPC with edge computing, and then I think about things about bringing data. The HPC capabilities closer to data sources like IoT devices, reducing latency, increasing processing speed. I mean, that to me is really, really cool. I can't wait
we
for that to happen.
we have a customer who has a cluster on a boat.
You
And
mean
the
like a
reason
yacht?
no, 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 like a seafaring, like that. And what they're doing is they're running data crunching on sea temperature. Like they're
Mhm.
dropping probes and stuff like that. And they're doing that sort of work right there on the ship. And then once it's all crunched down, satelliting it up. So absolutely, you can do that sort of stuff much closer and take advantage of the idea that okay, I've got a machine here with 10 cores. It could go real fast. Wouldn't it be neat if I had 10 of these machines and via HPC, I could have this virtual 100 core machine that would run the job much faster? You can stick that on a boat and get that faster. Now, the other side of it that I always kind of go back to is would have it been better just to sip that or just to siphon that data all the way back to the cluster sitting somewhere? You're going to have to decide. You're going to have to figure that one out yourself. But I will say this: you've got the option. And in some cases, like let's say you're at the North Pole or the South Pole, you may have to go with we've got to do it on site. No, by the way, heat's not a concern there. So run those things like crazy.
Yeah. Yeah, I mean, you're probably gonna have to get into something like low Earth orbit to be able to send the data through some sort of like,
Hmm.
satellite, communication. You talk about being in remote, distant places. You talk about kind of having a boat where it's actually testing water temperatures. You're
Yep.
probably way out there, into deep waters, far
Hmm.
away from, cell phone communications and towers. So probably doing something with low Earth orbits or LEOs, close enough to probably see space aliens.
Yeah, exactly. Just to get close enough to see them, and they're coming down there, and like, you're doing it wrong. Here, we'll give you something. I wish that was true. No, but here's the other thing about it though that I was really surprised by talking to a lot of researchers who are creating these type of software applications. In a lot of cases, as their models building, the steering that has to happen in order to end up with a really good model, you can't send the data up and get that right. It's got to be local. Going to your idea, I've got to keep it closer. So as these models are building and it's pulling those water temperatures up, it's kind of steering the way the application's going in terms of the logic to actually create that language model. So you can't have it sitting back, somewhere in Colorado. It's got to be on that boat in the middle of the Pacific. So once it's done, low Earth orbit, get the data over, everybody's happy. But you're going to have to get it closer to really be able to take advantage of what you're going on in terms of building that model in a reasonable amount of time.
I would think that cruise companies would be all over something like this, or have the current capabilities where they're doing cruise ships, right? They're out there everywhere. They're all over the international seas. They're going to different parts of the ocean.
If anybody who's watching, if you're seeing my face kind of warp out because Steve knows good and well I know about this, and I know a particular cruise line that is absolutely doing this, and what they're doing is fantastic because the example I got to see from them was the question of, is the passenger drunk? That was the question they were trying to do. And it literally, to me, it knocked me over because it was like next level customer service, because their point was not from a negative, but from a positive. If we have a guest aboard one of our ships, and I hope I'm saying that right because I got in a lot of trouble there because I can't remember if I was supposed to say ship or boat. One of them is like, you're not supposed to say that. I think it was ship. So anyway, they want to be able to say, uh-oh, we have a customer there who's potentially drunk. We need to go help them. Like, we need to send a crew member up there to help them get back. How were they doing it? They were doing it with ML. Where was the ML running? On board the ship. Because you can't, send that data up, wait to get an answer, and come back. They may have fallen overboard. So yes, that idea of getting it close like that. And and it's not even just, we're talking about that remote stuff, but there's also cases where there is like see if I can walk up on this one carefully, a great park to take your family for fun. And that's all I'm going to say. They're using that type of stuff too, from a security and to enhance the experience of the people who are actually there. By, for example, let's say there's a character that your kid is just in love with. So what you do is you have to give them money. They can give you the enhanced experience. They can literally find you in the crowd, assure that's who they are, talk to so-and-so, use the modeling, and actually make sure that when the person steps out to say hi to your kid, they're in an area of the park where there's fewer people, there's fewer chances for other people to come up to increase the possibility of that one-on-one experience. So everybody, if you think this stuff has not got some amazing capabilities, you're wrong. If you don't think, and this to me is where it really gets me, Steve. In some cases, it's almost getting to the point of the stuff is going to make things look magical. Remember that old quote about, if a society has sufficiently enough advanced technology, it will appear like magic. That's where this stuff is taking us with AI, ML, and being able to crush these big jobs using HPC to quickly get it out into the space. I'm so excited. I really am.
I think, and you're right. I think a lot of people are excited. I know me personally, I've really been excited over the last 6 months to see that just the trajectory of where things have been the last, 3 to 5 years, and then all of a
Mhm.
sudden, probably in the last maybe year, 18 months or whatever, is that you've seen this
Yeah.
huge explosion. You've never, and it's funny because I've never seen this massive amount of concentrated energy into a particular topic,
Mhm.
specifically around AI, where
Mhm.
there's more now than ever before. You have more access to things such as training, learning, education.
Yes.
Everything's online. It's very low to no cost in terms of being able to learn, adapt, and have a new skill, which is
Yep.
also kind of why I love it, because there's something new coming out all the time.
Hmm. Exactly. There was something I was looking at the other day, and I ground my teeth a little bit because it looked like, oh great, somebody has a new acronym for AI. Super duper. It was like gear reversed low language modeling with inherent redundancy. It's like, okay, just stop right there. This sounds like jibber jabber. But the point is that yeah, there's so many people working in the space coming up with these ideas, and I think some of them want to make it sound like it's something special, but in a lot of cases, when you really look at it, it's that old concept, those old principles injecting into the space because some of those principles stay the same. And I think more than anything, that's why we're seeing the explosion. We've been there, we've done that, we've learned the principles. Now let's put these principles in place with AI and ML, and we don't have to relearn it, and we can go even faster. What I'm curious about, though, is what is the new stuff that's going to be coming out of this? At some point, it's not going to be like, oh, a different, a new song, or somebody's done something funny, with Will Smith eating spaghetti. It's not going to be that. It's going to be something totally weird, something totally different. And I think the challenge is going to be for a lot of us is trying to get over that thing of, is this evil? Is this bad? And go, no, 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 no. It's just technology. It's the application of it is where we're going to have to ask ourselves, where are we exactly at with this sort of thing?
I listen to a lot of interviews with CEOs. I listen to a lot of a lot of people who are very very concerned around the social the social impact of on society with artificial intelligence.
Mm-hmm.
And there's a lot of skeptics in terms of saying, listen, it's great for the 10 million people who are already currently working in IT right now. What are we doing with the other 8 billion people on the planet that don't have access to this advanced technology? Right.
Mm-hmm.
It's kind of the how do we kind of shift the paradigm to get everybody involved? And I think it's going back to kind of like Maslow's hierarchy, which is kind of, when people don't have to worry about fighting for food and for struggle and things like that, they can then focus on things such as learning and training education. Anyway, but I
Right.
digress.
No, that's a
But
great point. That is no
yeah,
great. That is a huge deal.
yeah, but I think it's interesting because again, is you see AI almost in every aspect of our life, every aspect
Mhm.
of our society. Everyone is going to be interacting with some sort of AI entity in the next, 12 to 14 months, if not already
Mhm.
right now. I
Mhm.
guarantee you, if you're probably booking a travel ticket anywhere right now, is that you're probably going to be chatting with some sort of virtual agent.
Mhm.
That's probably an AI
Mhm.
chatbot, right? Um,
Mhm.
I think that I'm very excited about the landscape to see what happens. I know I need to continue to keep educating and to keep up pace, right? And I think again, it's that thing is you have to run as fast as possible just keep up. Uh,
Yeah, yeah, you do. And I will also this is something I've told a lot of people about technology. And there's no nice way to say this. If you've just oh my gosh, when did it start for me? When I it was probably about 1989, 1988, working, trying to get my degree in organic chemistry, starting to work with computers and stuff like that. The bug bit and has not let go of me since then. I still love technology. My goodness, I'm such a nerd. If you don't have that passion about it, this can be kind of a tough business because you got to learn your whole life. Yeah. And that's part of the fun for us is learning how to do these things. Not to mention exactly what you said. I'm back to the command line again. Yeah.
mhm.
That's awesome.
Wait,
So
where's the mouse?
don't need it. Just put it away. Put it away. It's going to slow you down. Just put it away. And it is that passion about it and the fun and the excitement. So I would say to a lot of people, and this is what I hope a lot of people get from this. Um, when it comes to technology, let's make sure the door is properly marked. It's real big. There's a big neon sign over the top that says everybody is welcome. Let's make sure that is there. But at the same time, let's not be ignorant and start walking into the crowd and shoving people towards the door because they may not want to do this. It may not be something they want to do. But I will guarantee you there's probably somebody in that crowd out there that you never thought about who's got a real heart for this stuff and just wants to, who's looking at it going, I'll never be a part of that. We need to make sure that they know HPC, AI, ML, the door's open. You are welcome. We need all the help we can get.
Yeah, somewhere out there, there's another Jeff Bezos or Jensen Hong or basically the next Mark Zuckerberg, right? There's the next innovator out there, right? Like you've got these people with a huge capacity to learn, and
Mm-hmm.
it's like they need to get in touch with the technology. That's what I really love about it. Um, yeah, I mean it's incredible.
And the applications of it are it's just ridiculous. I mean, I was thinking the other day, just going through the grocery store, just looking around, like there are so many applications for this stuff sitting here. There are so many applications. I want an application where I can show the thing, the water. Everybody does this. They'll pick up a watermelon, they'll thump it. Yeah, this one sounds good. You don't know what you're doing. Or my wife has got this thing where it's got a nice yellow bottom and the bands are real wide. That's a good one. No, that doesn't mean anything. But if I could train an ML model to pick out a great watermelon and it could be integrated into my glasses, so I could just, there's a good one. Whoo! Let me tell you what, 99-cent download will be rich in no time whatsoever. There's so many applications for this stuff. And I think sometimes we get ahead of ourselves thinking it's going to be something huge, like it's going to be able to fly the plane. No, back up. Don't need that. Watermelon picking, that
Yeah,
could be fun and interesting. I
yeah. Well,
like the idea of that.
we'll stay away from the no airline pilot flights for now.
Well, we say that. I don't know if you heard the story. One of our country's veterans, um, I believe what was happening was is he thought he had indigestion. Turns out when he got to the hospital, he was having a heart attack or something like that. Realized he couldn't drive himself. The man had a Tesla. Got in it, autopiloted him to the emergency room. He got out, told it go park yourself basically. That is amazing. That is incredible. When that stuff starts happening, that's what I'm talking about. Yeah, I still want my big truck that burns gas and I can go mudding it. But knowing that that thing is there and can do that for us, wow. And all we got to do is start learning about AI, ML, how to use HPC to run these big jobs. We could change the world. Exactly. There's some kid out there somewhere who can make this happen. And I cannot wait for them to do it.
Yeah, absolutely. Brooks, I can go on about this all day.
Oh, yeah.
I can't begin to thank you. So again, thank you so very much for joining us today. Thank you
Yeah.
for sharing your insights on this really important topic. I think high performance computing, again, it's very complex.
It is.
I hope we did it justice to be able to kind of break it down for our
we
listeners.
we
Um,
scratched the surface just a bit of this monstrous thing, but I'm hoping that by scratching that surface, we have enough people go, "Oh wait, I need to go look." Yes, you do. Yes, you
yeah,
do.
yeah. And Brooks, thanks again for having on.
Yes.
And
Thank you for having me.
Oh, it's a pleasure. Oh, anytime. And to all our listeners out there, thank you for tuning into this episode. I really hope that you found this informative and very fascinating, just as much as Brooks and I did. Again, we really appreciate your support on these journeys. Don't forget to subscribe to the Tech Travels podcast on your favorite podcast platform. Stay tuned for the next episode. And until next time, stay curious, but most importantly, stay informed and happy travels.
Absolutely. Bye, everybody.